Right. Good afternoon, all of you all. Good afternoon. Right. Good to see all of you all. But you would have liked to sit and enjoy your holiday a bit more at home after O levels. But generally, what happens is if you start early, it's always good when you're doing science. Is it clear? Right. Anyway, when new classes start, teachers are like peacocks. You know, peacocks. I've seen peacocks, they put their thing and they dance. Yeah. Most of the teachers like that. My advice to you is don't take all the advisors. Yeah. They are giving their perspective. Make sure you sit in a balanced position and what? Decide for yourself. Make sure you ask from your seniors and all when you select your classes. Clear? Because it's a proper selection that really matters. If you select well, then you have no problem. If you don't select well, then halfway through next year, that means after the first year, then you start what? Regretting. Yeah? Then you start regretting. Make sure that does not happen. Make sure you decide in the very beginning itself. And once you are set with a particular class, make sure that you keep on working as you should work. Is it clear? You should work. And then you keep on, you can gradually have a good flow as you go by. Okay. Now, like everything, this is just a journey. Now, from grade 1 to grade 5, you all got, before that was you all went in a smaller bus, but grade 1 to grade 5, you all got into a bus. Once you traveled, grade 5, you had scholarship. Okay. Some of you all did very well. You got down from that bus and took another bus from grade 6 to grade 11. Some of them who did not do well kept on going in that same bus, but you also have reached what? Grade 11 in a different bus, but the destination is what? Same. But the experience will be different. Is it clear? So you're traveling to Colombo. You can travel through Kandy Road. You can travel through Kurunagala. The experience will be what? Different. The experience is not the same. Now, once you hit grade 11, now you are started on another journey. But taking another bus. This is another bus. There. Making this journey memorable or sad is up to you. Making this journey memorable or miserable is up to what? You. There. Any journey is like that, no? If you are happy when you are traveling in a bus, you are happy. If you are sad when you are traveling in a bus, you are what? Sad. You can't. Nobody can make you happy. Even if there was a clown dancing in front of you, what? You'll be unhappy. So remember, this is just a journey you're going to take through. Make sure what? You make the best out of it as you travel. Okay? You'll learn a lot of experiences. You'll learn a lot of knowledge as well. But either way, make sure what? You enjoy the journey as well. Is it clear? Enjoy the journey as well. Now, when you travel, you must be sure now when you get into a normal bus. Now today you all came by bus, no? You all came to the bus stand, you saw a bus, you looked at the driver, you didn't even look at the driver. The fellow was not there. You just got in, sat and came. You didn't stand out, give a call, Machang, you went in this bus, this is the bus number, that's the bus driver's face. Did you take a photo of the bus driver, put on Facebook, ask whether he's a good driver, ask for ratings? Did you do that? No, no. You got in, you trusted the fellow, you came. Is it clear? Same way, in A levels also, when you select your teachers, make sure that at the end, once you select, to trust the person and the person's process. Normally, if you don't trust, however much, even if God from heaven comes and teaches you, even if Einstein comes and says, I'm Einstein, learn from me, if you don't trust the process, guaranteed it won't stick. Is it clear? You must always trust the process. If you don't trust the process, then guaranteed you can't achieve also. Because every time you will be in what? Doubt. Is it clear? Every time you will be in doubt. So my advice to you, after you select your teachers, make sure what? You trust the process. Once you trust the process, the destination will be reached. Okay, no? I will not talk too much about myself. The result booklet is there. You can read it. Not now. Take home and read it. Is it clear? Most of you are here because your sisters, brothers, they studied and they are here. They told to go. Therefore, what do you call? I don't need to tell too much about that. You just need to what? Make sure you understand what's happening. If you have a doubt, always ask. There is no problem. You can see after class or before class. So I'll be here normally. You can come and clarify your doubts. You have no issue at all. Okay, no? Right. About A levels, A level physics. Different people will give you different perspectives about physics. It's very difficult. Very dangerous. Maybe you should select a different subject. You're asking the wrong person, guaranteed. Yeah. You're guaranteed asking the wrong person. Sri Lankans are very famous to ask important things from wrong people. You will ask about university from an uncle who has never gone to university. You know what his answer will be? Ayyo, university poiti verilla. Endanalum strike tha. He will tell. He has not even gone to university. He has gone. He has stood in front of the bus stand. There's a bus stand in front of university. That's the only place he has gone. The maximum location he has been. But what happens? You will ask the important questions from what? Wrong people. So once you come to A levels, remember, try to ask the important questions from what? The correct people. If you ask important questions from wrong people, they'll always give you what? Wrong answers. Understood? Yeah. And also when you come to A levels, remember to say no. You should know the art of saying no. Sometimes when you say no, you try to explain yourself. Can you come today? I can't come. Why? I can't come today. Why? I can't come today. Some of you go to the extent of no, today I have some work to do at home. My mother is not well, therefore I have to go with her. You have to explain yourself. If you try to explain yourself, if somebody is trying to dig and ask, make sure you don't give the correct answer. Always learn the art of saying what? No. Because if you don't know the art of saying no, someday sitting and studying for long hours will be a problem. Every 5 minutes, somebody will wake you up and send you to the shop, send here, sweep the house, go there, go up. That means what? You will not be able to concentrate and do your work in the required time. Make sure you know the art of saying what? No. If you know the art of saying no, you will learn a lot of things, but there are some responsibilities that you have to do that also you can do. But not in the time you're sitting and doing your what? Required work. Okay, no? So learn the art. Sometimes you will say, not nice, no. Not nice indicates, if you think it's not nice, it indicates you are what? Your character-wise, you are weak. If you have to say no, finished. I can't come. I have to go for a class. You don't have to explain yourself why not, this, that. If that's the case also, what? You have no problem here. So make sure what? Just two things for now. As we go along, we'll talk. But generally, the art of saying no, ask the correct, don't ask important questions from what? Wrong people. Third one, select and always trust the process. Understood? Learn the art of saying no. Number two, don't ask important questions from what? The wrong people. Third one, what? Trust the process. Three things. That's all you need to remember for now. And everything at the end now, today you saw some of my old students coming here from Moroto and all. They're the ones who did A levels in the most hardest time. I think the two sisters are here, twins. I'll come late and talk. During the most hardest time, that means COVID, no school, no nothing, just through internet. But they kept on doing the work and they have reached their required goals and they are keeping on going. So that's the most important thing. Okay. So Just remember that in your head, right? Okay then. Like I said, physics, generally in your syllabus wise, you have 11 lessons. Huh? You have 11 lessons. I'll give a basic introduction. Huh? First one is generally units and measurements that we start today. Today we start this lesson. Units and measurements. Don't write, just look. Second one is mechanics. Third one, waves and oscillations. Fourth one, thermal physics. Fifth one, gravitational fields. Sixth one, electric fields. Seventh one, electricity. Eighth, magnetic fields. Ninth one, electronics. 10th one, properties of matter. Properties of matter. 11th one, matter and radiation. Matter and radiation. Here you go. Your 11 lessons. Okay. Now remember these three. This is known as the classical part of physics. You call it classical physics. Just like classical music, normally when you learn music, they teach the scales A, B, C, D, or E, G, B, D, F, F, A, C, E. They teach everything, no? They teach you everything from basics. So this is what? The classical part of physics. Normally this is pre-1800. Pre-1800, anything that they have found before 1800. So generally the classical part of physics is there in the beginning. So they normally teach that. We have to teach that in detail. So up to about half of this, or the half of the first part here, that normally falls under the first year. That normally falls, half of this falls under the first year. Grade 12. Huh? Now you'll wonder, my God, so much for the second year. Remember, these things are actually applications. If you know this part very well, especially the mechanics part, these are very, very easy. So this part actually is the core, it's the heartbeat. Once you know this very well, scoring in these sections is very, very easy. So remember, grade 12 work is very, very important. If you ask from somebody and that fellow said physics is difficult, that's because grade 12 work, the fellow did not do well. Generally, that's the situation. Huh? Grade 12 work, if you don't do well, guaranteed you will have what problem? Here also the same, even in university same. Grade 12 work, if you don't do well, guaranteed you will have what? Problem. Understood? Guaranteed you have problem. So make sure your grade 12 you do well. Huh? Grade 12, do not miss anything. Make sure you're focused. Sometimes you might be doing, let's say you have to go to school, you're doing a sport. Once you are doing a sport, make sure you continue doing it. Clear? Otherwise, when you stop it at once, now you will say your parents say, now you do A-levels. Make sure you stop it. Focus 100% on your studies. Generally, what happens is, when one part of your life is stopped, your brain stops working. You go into what? Some kind of sadness or a dark place. And therefore, what? You can't perform. So anybody is doing sport, make sure you're doing sport. If there is somebody who has not done sport, don't start now. If there is somebody who has not done sports, please don't start now, because you all don't know the art of balancing the workload. Therefore, don't start now. Normally, if you're doing sports from under 12, 14, 16, 18, you know, your first term marks go up, your second term marks go down. Sometimes your mark is less than 20 marks. You get scolded, you get beaten, you study. So you learn the art of what? Slowly pushing your marks until what? Grade 11 comes, you're around 60 or 50 marks. That takes a lot of time to balance, huh, if you're a sportsman. If you're not a sportsman, you don't know that. Now you start, that's the worst time you need to start what? Playing some sport. If you want to play a sport, make sure you can play badminton or go to a pool and swim or do something or play cricket or whatever. but not comparatively, you're going to have a problem. Clear? The ones who are doing what you call Candy is very famous for Interact and all of that. Remember, I was telling this last year as well. There are some fellows, Interact and all, you have to do projects. No, there are interactors here, you know what I mean. You do projects. There are some 90 or 100 projects a year. 90 projects a year, you divide by what you call 12 months. How many projects a month? How many projects? 90 divided by 12, if you just look the average, even more than 7 projects. Can a normal human do that? I don't think so. Normally, when you have things like that, you be very careful. Choose what is important. Because in that case, most probably will be walking on the road, asking for advertisements so that you can what? Do the project. And majority of the time you will be on the road. So those kind of things don't take now, especially if you are doing science. Because you have no time to waste on the road. Yeah. Last year also I told this because I understood that most of you all unknowingly start doing Interact, and unknowingly what you waste a lot of time. And that time lost you can never what? Recover. Clear? Nothing against Interact. But the only problem is what? It eats your time. Clear? It eats your time. Next is this. If you take gravitational fields, electric fields, electricity, magnetic fields, this is the modern part. 1800 to maybe 1950, before the World War. During that period, whatever that was found, you'll learn. Then loads of electronic development occurred during the Second World War. So 1950 onwards, whatever they found, you will learn there. Normally, this part here, properties of matter, generally it's connected to mechanics. Now you might wonder, sir, why did they put it there? That's just to balance the load. Now you're learning a lot of new things here, no? Applications. By this time, you're mentally mongal. Now by this time, they had to what? Just balance it off. Okay. Just like giving you ice water to drink when you're running. Just to cool you off. Just to cool you off, they have what put properties of matter, which is generally a mechanics section. And then finally, matter and radiation. Here we'll be talking about nuclear fission, nuclear fusion, nuclear equations. How to use medical physics. Now this part is actually a medical physics part. Medical physics part. We talk about how X-rays work. We talk about how radioactive particles work. All of that we do it here. So this part is generally an application-based one, which is generally called modern physics part. It's a medical physics part that you will learn. Okay, no? So that is your general syllabus. Normally they give for about 30 months. But these are your general syllabus. Now, we start from this. Units and measurements. Reason we start there is physics is a science of measurement. Without measurement, you can't verify the science. So once you measure, then only what you can verify. So remember, these are always a science of measurement. And physics is actually everything. You are sitting in that chair because of physics. You walk because of physics. You talk because of physics. You laugh also because of physics. You lift certain things also because of physics. Is it clear? You hear because of physics. Have you ever wondered why your ear is this shape, like this? Why is it that shape? This inner part is shaped like this. Why? So you can clean your ear much more easily. Huh? Why do you have this small part here? Touch and see. Do you have one? Why? Huh? Why do you have that small part? That is also because of what? Physics. Your hair grows because of what? Physics. Your nails grow because of what? Physics. Technically, you are here also because of what? Physics. We'll talk about that later. Not today. Is it clear? Therefore, technically, everything that you do, every motion that you see, When you travel today by bus, the reason you came is because of motion. You came because of what? Physics. You breathe because of physics. You will learn that here, how your lungs work. It's because of physics. Clear? Your transportation, that means whatever you eat, you drink, your blood circulation, all of that happens because of physics. So therefore, remember, everything that you do is what? There is a chemical component, there's a biological component, but the motion part is controlled always by what? Physics. Clear? So therefore, remember, you are learning something that is very important, which is very practical. Very practical means there is loads of what? Applications. Every single section that you do, there is loads of what? Basic applications that you will always see. Okay, no? Basic applications that you will always see. Right. Okay, then. This is the general syllabus. Now, you might ask me before I start the lesson, so what are the books and all that I should buy? Clear? Now, there is a resource. Resource books are given by the government. Resource book is there every lesson wise. Now, these resource books, you can technically buy it from any bookshop, or there is a government, website called EduHub. From EduHub, you can download. Now, no need to download all the lessons and work, but lesson by lesson, take it, download and keep it. If you have a lot of money, then you take a printout and keep it. Is it clear? There is no problem. Shh, don't write, just look and wait. Then, some of you all ask, what type of book should I use? Additional book. Should I use additional books? Is Sir's note more than enough? My advice to you is the more questions you can do, the better. But my general advice is you can take Professor Gee Kianaga's book. What? Professor Gee Kianaga's books. Yeah. Professor Gee Kianage, you have the first unit now you can buy. Don't go and buy all the units and keep at home. Some of you all have this small, mental illness. You go and buy a lot of books and keep and look at the books and you are very happy. Sometimes you have a lot of books at home. You are not even read. Last year book fair, you can buy books of 50,000. Only one small book, 750 rupees, you will read. The rest, 49,250 is still there. This year book fair also, you can buy some more books of 50,000. At the end, what? You're filling your room with books and you're telling your mind mentally, the more the books I have, the more educated I look. In reality, no. The more books you read, the more better, more informed you are. So make sure you buy one book. Once you finish that book, then the next lesson one. You might say, sir, will the books be over? No. Books are normally what? Printed again and again. There. They don't print one book and sell the book and say, I won't print again. There. Books are always what? Printed over and over again. So therefore, there is no need to buy and keep all the books at once at home. Yeah. That's also unwanted pressure. You know why? You'll always look at the books that are not taught yet and then what? Get depressed. Ayyo, so much of things to learn. Make sure one by one you go forward. Simple. Next, now they have the common questions people ask. Huh? Sir, should I buy? What past paper book should I buy? My advice to you, don't buy past paper books yet. Why? 2023 exam still not held. 2022 paper is not still added. Some books 2021 is not added. You're doing in 2025. If you can buy the past paper book now, by that time you'll walk like a picture car and ask him everybody, Ayo, give me this past paper, give me this past paper. That past paper won't be there. Make sure you wait for some time. Once all the books are printed, then go and buy it. Otherwise, you'll have one part of the book and then what? Walk around. They won't give. They also don't have. Is it clear? Therefore, don't be in a hurry to go and buy. You might ask, sir, what brand is good? Is there a brand for past papers? No, there is no brand for past papers. You have brand for shirts, brand for underwears, brand for banians. There is no brand. Anything given by the education department, therefore what? Same marking scheme is given. Sarasavya can't print whatever marking scheme that they like. Kodage can't print what? No, it's a fixed marking scheme. They just put different names and they print. Okay, no? So don't be in a hurry for that. Once all those papers are added in the print, you can go and what? Right. Okay, no? That's about it. Like I said, any questions as we go along, you ask and clarify. And we'll start the lesson. Okay, no? Take your books, right topic. Units and dimensions. Units and dimensions. Right. Shh. Look, Velo. Like I said, shh. Physics here, science and measurement. Today we're going to start from the foundation. From the basic building blocks. Clear? From the very base we start. Now remember, a physical quantity, now you heard the word, huh? Physical quantity. A physical quantity is a quantity that is measurable. Not unmeasurable, huh? Measurable. So physical quantity is a quantity that is what? Measurable. In physics, what we are doing is, we are studying those physical quantities and trying to what? Take measurements. Yeah. We are studying those physical quantities and we are trying to take measurements. Right. There are 7 fundamental physical quantities. How many? 7 fundamental physical quantities. You call them fundamental because everything else is built from them. Fundamental quantities. These are your 7 fundamental quantities. Have a look. First one, mass. Second one, length. Third one, time. Fourth one, thermodynamic temperature. Thermodynamic temperature. Thermodynamic temperature. Electric current. Electric current. Substance of matter. Substance of matter. And something very new for you all. Luminous intensity. So how many physical quantities are there? 7 fundamental physical quantities. What are your 7 fundamental physical quantities? Mass, length, time, thermodynamic temperature, electric current, luminous intensity. Remember, every single thing is built from these basic foundations. If I put the units here, mass normally you all know measured in kilograms, length is measured in meters, time is measured in what? Second. Thermodynamic temperature is measured in Kelvin. Capital K, not Celsius. Huh? Scientific measurement of temperature is always what? Kelvin. This is Kelvin. Electric current measured in amperes. Good. You measure in ampere. Now this in chemistry all learn. Substance of matter, moles, MOL. This is kind of new for you all. Luminous intensity, we measure using a unit called candela. CD. This is called candela. Now in A-level physics, we don't talk about this unit a lot. Maybe university years. University also second year. But generally, these are your what? 7 fundamental physical quantities. So you have 7 fundamental means basic. These are the foundations. Imagine 7 columns. Everything else is built from that. Is it clear? 7 fundamental physical quantities: mass, length, time, thermodynamic temperature, electric current, substance of matter, luminous intensity. Clear? Luminous intensity. Okay? Right. Now, there are 2 supplementary quantities. There are 2 supplementary quantities. Yes, 7 fundamental, but without these 2, you can't get shape. If you take this building, you have a shape. You take your pencil case, you have a shape. Is it clear? You take your pen, it has a shape. Shape means angle. So when angles are given, there is always what? Shape, and shape is important. So supplementary quantities, there are 2 supplementary quantities. One is going to be what? Plane angle. One is going to be plane angle. Remember, now in O levels, you all learn to measure angle using degrees. But scientific measurement of angle is not degrees. Plane angle we measure using what? Radians. Rad. I'll put in brackets if you want. We measure using what? Radians. And then you have solid angle. Solid angle. Solid angle is measured in a special unit called steradians. SR. Steradians. So you have 7 fundamental quantities. Tell me, what are your 7 fundamental quantities? Mass, length, time, thermodynamic temperature, electric current, substance of matter, luminous intensity. And you have 2 supplementary quantities. What are they? Plane angle, solid angle. Plane angle measured in radians. Solid angle measured in steradians. Okay. Let's write. Let's write. There are 7 fundamental physical quantities. There are 7 fundamental physical quantities. They are right below. Mass, length, time, thermodynamic temperature, electric current, substance of matter, luminous intensity. Put the units also carefully. Mass is measured in kilogram, length in meters, time in seconds, thermodynamic temperature in Kelvin, electric current in ampere, substance of matter in mole, luminous intensity candela. Luminous intensity candela. Okay. Right. Okay. Next one. There are two supplementary quantities. There are two supplementary quantities. Write down. Plane angle measured in radians. Solid angle measured in steradians. Okay. Right. Now all your life you have measured using degrees. What is this new thing? Radians. So there is a relationship. There is a relationship between what? Radians and degrees. There is a relationship between what? Radians and degrees. So here you go. This is the relationship. Relationship between radians and degrees. Radians and degrees. So this is the relationship. Huh? Look carefully. Pi radians. These are the same pi you learn in maths. 22 divided by 7, 3.14. In science, normally there's only one pi here. Okay, 22 over 7 or 3.14. Pi radians is how much? 180 degrees. This is your relationship. So if somebody asks you, what's the relationship between degrees and radians? What's your connection? Pi radians equals 180 degrees. Okay, no? Quickly write subtopic. Relationship between radians and degrees. Relationship between radians and degrees. Box it. Pi radians equals 180 degrees. Pi radians equals 180 degrees. Okay. Right. Look at this. Now let's do some conversions or calculation. Observe this carefully. I'll do a small example. First one, I'm going to convert 5 degrees to radians. 5 degrees to radians. Look at the board. Huh? Don't write. Look. 180 degrees equals pi radian. That's the main rule. No? 10 toffee is 100 rupee. 1 toffee how much? What do you do? Pi over 180. Can you remember all your work? 10 toffee is 100. 1 toffee how much? Now they're asking for 5 degrees. 5 degrees means pi over 180 multiplied by how much? 5. Now you simplify this. Now you can write in terms of pi, but you simplify this carefully. Pi 18 times 3 you have 30, you have 6. Pi over 36 radian. Pi over 36 radian. Clear? So what I have done? I have converted 5 degrees to radians. Okay, one more example. before you solve alone. Let's say I need to convert and I need to find 12 degrees when I convert to radian. So how do I do the conversion? Again, look, 180 degrees equal pi radian. 1 degree equals pi over 180 radians. 12 degree equals pi over 180 multiplied by how much? 12. Now your table should be good. Now you're just after O levels, so you're in good form. 12 times 1, 6 left, 60 you have 12 times 5. Pi over 15 radians. Yeah, pi over 15 radians. Okay, no? So this is how you convert degrees into what? Radians. Is it clear? This is how you convert degrees into radians. Write these two examples. Write these two examples. Come in front. Okay. Right. Don't be in a hurry now. Slowly improve your speed. There's a speed also you must get used to. At once you won't go to that speed, but slowly what? You have to get used to that particular speed of writing and calculating as well. Especially the calculating part. Sometimes you are generally a bit slow in the calculation part. That try to improve, but you will improve as you go along. Okay. Finish writing? Anybody still writing? No one. Right. Okay, then. You can convert the following into radians. Quickly convert the following. Convert this into radians. Right? Conversion. Sorry. So first one, 15 degrees. So you know the basic rule, no? 180 degrees is pi radian. 1 degree pi over 180 radians. 15 degrees pi over 180 multiplied by 50. Pi over 12 radians. Okay. Next one is 30 degrees. 30 degrees. Now you know the factor, no? Pi over 180. Look at the short method. No? Pi over 180 multiplied by how much? 30. You will get pi over 6 radians. Third one, 45. Pi over 180 multiplied by 45. That's pi over what? 4 radians. Next is 60. 60 degrees. Pi over 180 multiplied by 60. Pi over 3 radians. 75 degrees. Pi over 180 multiplied by 75. Be a bit careful. You can quickly divide this by 15. 15 times 5. 15 times how much? 12. Pi over 12 radians. Pi over 12 radians. Pi over pi over 2.4. That means you divided this directly. And there is no problem. I do keep in fractions. Okay. You can divide any way you want. You can substitute for pi also 22 over 7. Normally, standard method is we keep in terms of pi. Clear? Radians we always keep in terms of pi. Okay, no? Right. Eighth one, I think 90 degrees, no? 90 degrees. Pi over 180 into 90. Pi over 2 radians. Pi over 2 radians. 120. Pi over 180 into 120. Divide by 60. 60 times 2 and 3. 2 pi over 3 radians. Next is 135, I think. Pi over 180 multiplied by 135. If you divide by 45 even, 45 times 3, 45 over 4. 3 pi over 4 radians. That means it's okay. Okay, you can divide by other values 3, 5, and anyway get the smallest ratio. Some of you all kept your answers, I saw, not in the smallest ratio. You can divide that further, and keep it in the smallest possible ratio. Okay, no? 11th one, 150. Pi over 180 into 150. Simplify it. You can see here 3 is the easier way to divide up and bottom. 5 pi over 6 radians. 5 pi over 6 radians. 12th one, how much? 225. 225 degrees. Pi over 180 multiplied by 225. If you take 45, 45 times 5 pi over 4 radians. 5 pi over 4. Put your phone on silence, huh? Right. Anybody needs to write this or still writing? Put your hands up if you're writing it still. No one? Okay. Next one, I think I gave 270, no? 270. So I'll slide it this way. 270. Pi over 180, 270. You can divide by 9, no? 3 pi over 2. 3 pi over 2. What's the next one? 350. 315 degrees. Pi over 180 into 350. 7 pi 45 times 4. 15 one. 405. Pi over 180. That's 9 pi divided by 4. Okay. 9 pi over 4. That's all. 540. Pi over 180 times 540. 3 pi radians. 3 pi radians. 720. Pi over 180 into 720. 4 pi radians. Okay, no? How many of you have got all this correct? Right, good. Once you got 1 or 2 calculation errors, quickly correct it. Quickly correct it. So first things first, huh? Whenever they give a scientific angle, quickly convert to what? Radians. Base requirement is that. Yeah. Right. Okay. Anybody still writing this? Anybody? No one. Right. Now we'll convert radians to what? Degrees. Look at this carefully. Yeah? Earlier page, I'll show some example. Will. How do you convert radians to degrees? Look below. Let's say you need to convert pi over 3 radian to degree. Now don't panic, just be, it's very simple. Pi radian equals what? 180 degrees. Whatever you do to the right hand side, you must also do to the left hand side. So if you divide this by 3, so divide that also by how much? 3. Now pi over 3 radian, that is equal to how much? 60 degrees. Pi over 3 radian equals what? 60 degrees. Okay, no? So it's very simple when you convert radians to what? Degrees. Because if you divide the right hand side by 3, left hand side is also what? Divided by 3. Right hand side divided by 4, left hand side also divided by what? 4. Okay, no? That's the basic way you do it. Quickly do the following conversions. If you want, write this example down. Multiply. Okay, no? Quickly convert. Quickly convert. See there are answers like this. Pi radian 180 divided by 4 means 45 degrees. Okay. Second one, pi over 5 radians 180 divided by 5. How much? 18 times 3, 36 degrees. Third one, 2 pi over 5 radians 180 multiplied by 2 over 5, 72 degrees. Fourth one, 3 pi over 8 radian 8 times 1, 8 times 2 for 22.5. 15, 7, 6. 67.5 degrees. You all got this? Fifth one, 5 pi over 8 radian. 5 over 8 multiplied by 180. Don't be in a hurry, carefully simplify. 8 times 1, 22.5. Now you multiply. 22.5 means 5, 10, 12, 11. 112.5. 112.5. Okay. 112.5. Next one. Two pi over 9 radian. 2 over 9 multiply by 180. 9 times 1, 9 times 20, 40 degrees. 40 degrees. Seventh one, 7 pi over 9 radians. 7 over 9, 180. 9 times 1, 9 times 20, 140 degrees. 140 degrees. Eighth one, 5 pi over 12 radians. 5 over 12 pi radians is 180. 12 times 1 for 60 I have 5. 75 degrees. Okay. 75 degrees. Ninth one, 11 pi over 12 radians. 11 over 12, 180. 12 times 1, 1 here. For 60, you have 15, no? Now careful, huh? 15 times 1, 15, 1 left. 15 times 1 and 6, 165. 165. 165. Then 13 pi over 15. 13 pi over 50. 13 pi over 15. 13 over 15 into 180. 15 times 1, 30 you have 12. 12 times 12, 144. Another one added, 156. 156 degrees. How many of you have got all of this correct? Right. Small adjustments or corrections make it. Huh? Generally, the theory is very simple. So most probably you made some calculation error when you divided. Okay, no? So right. So far, what have you learned? 7 fundamental quantities. What are your 7 fundamental quantities? Mass, length, time, thermodynamic temperature, electric current, substance of matter, luminous intensity. Answer this question. Huh? Thermodynamic temperature was the unit. Electric current was the unit. Luminous intensity was the unit. Candela. Okay. Substance of matter was the unit. Moles. Okay. No? There are how many supplementary quantities? 2 supplementary quantities. What are your 2 supplementary quantities? Plane angle and solid angle you measure using? Solid angle you measure using radians. Plane angle you measure using radians. What's the relationship between degrees and radians? Pi radians equals 180 degrees. Okay, no? Is there anybody still writing this? No, right. Okay, now we move on. So we know 7 fundamental quantities. We know 2 supplementary quantities. Now we build on this. Derived quantities. Derived quantities. Listen. What do you mean by derived quantities? Physical quantities that we make using fundamental quantities are known as what? Derived quantities. Again, listen. Now. Physical quantities that we make using fundamental quantities are known as what? Derived quantities. So what are we using? We are using fundamental quantities to make these quantities. Have a look. We start with something simple. Area. What is area? Length multiplied by breadth or whatever. So what are you multiplying? You are multiplying 2 lengths. So here length multiplied by another length. What is length? Length is a fundamental physical quantity. Using fundamental quantities, I am making what? I am making what? Derived quantities. So area is what? A derived quantity. So I use fundamental quantities and I make a new physical quantity. Those are known as what? Derived quantities. So area is 1. Look at the next one. Volume. Volume is going to be what? Length, breadth into height. So you are multiplying 3 lengths, get technical. Length into another length. So length is a physical but fundamental quantity. Using fundamental quantities, I'm making what? A derived quantity. Volume is what? A derived quantity. Can you see? Using fundamental quantities, length is a fundamental. I'm making a derived quantity. Third one, have a look. Linear density, something new for you all. Linear density. Linear density is mass divided by length, not volume. That's why I told you this is new. Linear density is mass divided by what? Length. Mass, fundamental. Length, fundamental. Using fundamental, we make what? Derived. Mass is a fundamental, length is a fundamental. Using fundamental, we make a derived quantity. Next is surface density. Surface density. Surface density is mass divided by area. Now mass is a fundamental one. Area I can make using fundamental. I can multiply by length into length. And then I will get what? A derived quantity. Is it clear? So areas I can break into fundamental. So using fundamental, I can make what? A derived quantity. So surface density is what? A derived quantity. Clear? Surface density is a derived quantity. Look carefully. Yeah? Fifth one. These are the one that you all know. Volume density. Volume density. Volume density is mass divided by volume. Mass is fundamental. Volume I can find using fundamental. So volume density is what? A derived quantity. So using fundamental quantities, if I can make a new physical quantity, that physical quantity is called what? Derived quantity. Actually 7 fundamental, 2 supplementary. Everything else is built on those 7. That's why we call those 7 what? Fundamental quantities. Okay. Look at this one now. Speed. Tell me the equation. Speed is distance over time. Distance over time. What is distance? Distance is a length. Length is fundamental. Time, fundamental. Using fundamental, I'm making a derived quantity. Speed is a derived quantity. 7. Velocity. What is velocity equation? Displacement over time. Displacement divided by time. Displacement over time. Displacement is a length. Fundamental. Time is fundamental. Using fundamental, we make what? A derived quantity. Velocity is a derived quantity. 8th one. Acceleration. Tell me the equation. What? Velocity. Acceleration, the equation correctly is change in velocity. Huh? Change in velocity divided by time. Now change means final minus initial, which means that is also velocity. Velocity I can make using fundamental. Time is also fundamental. Using fundamental, I can make what? A derived quantity. So acceleration is going to be what? A derived quantity. 9th. Force. Tell me the equation for force from O-level knowledge. Mass into acceleration. Mass into acceleration. Mass into acceleration. Mass is fundamental. Acceleration I can find using fundamental. Therefore, force is what? A derived quantity. Force is a derived quantity. 10th one. Pressure. What's the equation for pressure? Force over area. Force over area. Remember in physics, we give another name for this. Pressure is also known as stress. Not the medical meaning of stress, but the mechanical meaning of what? Stress. Force per area. Force I can find using fundamental. Area I can find using fundamental. Pressure or stress is what? A derived quantity. Okay, now clear? So 10 is here. What about the units? I'm going to put the base units. Huh? What do you mean by base? Fundamental ones. Kilogram, meter, second, Kelvin, ampere, mole, candela. Using those. Now length is measured in meters. Here also meter. Meter means m square. How do I write like that? Using indices knowledge. I hope you remember indices knowledge. A to the power n multiplied by a to the power m. That's going to be a to the power n plus m. Bases are same means powers will add. Okay, no? Next is a to the power n whole thing multiplied by m. What is it? A n m. These two are multiplied. Okay, no? Right. Now look at this. Meter to the power 1, meter to the power 1 multiplied means meter squared. Here, meter, meter, meter means 1 m to the power 3. Mass is measured in kilogram, length is measured in meter, kg m minus 1. Surface density, mass is measured in kilogram, area is measured in meter squared. What's your unit? kg m minus 2. Mass is measured in kilogram, volume is measured in cubic meter. What's your unit? kg m minus 3. Speed, distance measured in meter, time in second, take on top. If I take on top, what's your answer? ms minus 1. Displacement measured in meter, time in seconds, take it on top. What's your answer? ms minus 1. Change in velocity, remember, is also a velocity. ms minus 1. Here s. What is your answer? I'll write here ms minus 2. Mass is measured in kilogram. Acceleration measured ms minus 2. What is your base unit? kg ms minus 2. Don't put Newton and all. Those you'll learn later. You're writing in base units. Force kg ms minus 2. Area is meter squared. Now be careful. 1 meter cancel off. M goes on top. kg m minus 1 s minus 2. kg m minus 1 s minus 2. If you want, I will separately show it for you all. Again, look below. Force is measured kg ms minus 2 divided by meter squared. 1 meter will cancel off. If 1 meter cancels off, what will you get? You will get kg s minus 2 m at the bottom. Bring the m on top. Then you have kg m minus 1 s minus. Okay. So using fundamental quantities, if you make a new physical quantity, what do you call it? Derived quantity. Yeah, derived quantities. Let's write it below. Let's write. Let's write. Using fundamental quantities, using fundamental quantities, using fundamental quantities, if we create a new physical quantity, 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 these new quantities are known as derived quantities. These new quantities are known as derived quantities. These new quantities are known as derived quantities. Consider the following examples. Consider the following examples. Consider the following examples. Right, Bill, one by one. Okay. Right. Ah. Right. Look, 11th one. Work done. Tell me the equation. Work done is force into wrong, huh? Don't say distance. Force into what? Displacement. Yeah. Force multiplied by, normally in O levels, you will just tell that in O levels it's okay, but not in A levels. Yeah. It doesn't mean that whatever you learn in O levels is wrong. O levels, whatever the depth is not important. But when it comes to A levels, the depth is what? Important. Exactly, you should know what you're doing. Force into displacement. Now, force you can find using fundamental quantities. Displacement is a length. Therefore, it is a derived quantity. 12th one. Look carefully. Kinetic energy. Kinetic energy. Half mass into velocity squared. It's okay. Velocity squared. Gravitational potential energy. Can you see? Now, mass is fundamental. Velocity I can find using fundamental. Therefore, this term is what? A derived quantity. Yeah, it is a derived quantity. Gravitational potential energy. Gravitational potential energy. Tell me, mass into acceleration due to gravity into height. No? Mass into acceleration due to gravity. Acceleration due to gravity. Multiply by what? Height. Multiply by height. Mass is fundamental. Acceleration I can find using fundamental. Height is a length, fundamental. Is what? A derived quantity. 14. Sometimes you all hate this section in O levels. Moment of a force. Can you remember? Clockwise moment, anti-clockwise moment, all that stories. So what's the equation? Force multiplied by perpendicular distance to the pivot point. Pivot means rotational point. Perpendicular distance. Perpendicular distance to pivot point. Or rotation axis also correct. Huh? Now this is a pivot. Around this, the door will move, hinge. Force I can find using fundamental. Distance is fundamental. Therefore, these what a derived quantity. Please look at the board now. There's another word we give for this in A levels. We call this torque, not T-A-L-K. Torque, T-O-R-Q-U-E. If you watch any what do you call racing movie or whatever, or if you are interested in vehicles, they'll talk about always what the torque. What is the torque output? Okay. Torque is technically what moment of a force. It's just the posh name. Moment of a force is just force into perpendicular distance. Torque is actually what? The scientific basis name. Check and see. If you watch Formula 1 F1, the car comes to the pit stop. Do they take a spanner and then what little slowly remove the what you call nuts to change the vehicle? No. They use something called a mechanical or electronic torque wrench. Torque wrench. It's already programmed. The moment the car comes, pit stop, flow in front, zzz, 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 remove, tire in, zzz, 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 finish, gone. Clear? That means what? The thing is rotated, the nut is rotated to a particular torque. They won't rotate more than that. Now check and see. Now sometimes, let's say your father drives the vehicle, tire puncture. Check and see. You use the old method. You climb on top of it. Sometimes the fellow is standing on top of it and try to tighten it. You don't tighten nuts like that. What will happen? The threads will give away. And if the threads give away in a bad moment, you are going, tire will go somewhere, you will go somewhere. Is it clear? So threads only hold the whole mechanism together. So there's a required torque, specific torque. The wrong way of tightening something is just you keep on tightening until it's very tight. Check in sometimes your water bottles, your mom will tighten and give, you can't even open drink. You're asking everybody, I'm opening it because you can't open. But it's so tight so that, it's tightened so that please don't drink this water. Like that only they tighten and give. Generally, general torque required enough. Otherwise, you tighten it too much, the threads get what? Stuck. That's why you can't open it back. Because the threads are what? Now stuck into the metal. Clear? Right. So this is called what? Torque. So moment of a force technically is known as what? Torque. So if I put the units here now, force units are kg ms minus 2. Displacement is m. M and m put together, how much? Kg m squared s minus 2. Kg m squared s minus 2. Now look, next one. Answer this now. What is the unit of half? What's the unit of half? What's the unit of half? No unit, no. No unit means what do I put? 0. Half. No unit means what do I put? Half. So no unit, no. No unit now. You put unit here, no? My question, what am I going to put here for unit? No. Don't put anything. These are your first special note comes. What do you mean by special note now? In your A-level exam, you have MCQ paper. 50 MCQs. Essay 4 structured, 4 essay. 4 structured, 4 essay. MCQ 50 MCQ, 1 MCQ, 1 mark each. So 50 marks of the paper comes from the MCQ. Now MCQ is directly based on what? Fundamental concepts. If you know your fundamental concepts, guaranteed you can what? Score. Clear? Now most of the fellows, now you'll read the result sheet and all. Generally they score, if you are getting a very big good, if you're upping the Z score to a very high value, your what you call MCQ should be more, you should get more than 40 MCQs correct. Yeah, more than 40 MCQs correct. Now, getting more than 40 MCQ correct is not an easy job. It is actually difficult. But there is also basic things. I mean, if you know the fundamental theories behind it, getting more than 40 MCQs correct is not so difficult. Because your 40 MCQs is based on 964 special notes. If you are there from the very beginning till the very end, you will complete what? 964 special notes. If you know your 964 special notes, you have no problem in getting more than 40 MCQs. What? Correct. There. This is your special note number 1. If something is unitless, no unit. Unitless means we always put what? 1. Unitless 1. Mass is kilogram. Velocity is ms minus 1 squared. Now what? kg m squared s minus 2. So unitless means, I'll separately write that. Unitless means always what? 1. Don't say half, 5, 3, 2, what? Nothing. Unitless means 1. Clear? Understood? So now don't go and say that fellow taught half is equal to 1. Nah? I never taught half is equal to 1. I said unit of half is unit plus is 1. Clear? Sri Lankans are very famous for what? Misrepresenting. Half has no unit. Unit is not there. Unit nahi. No unit means 1. 1 times mass kilogram velocity ms minus 1 squared. kg m squared s minus 2. Mass is measured in kilogram. Acceleration ms minus 2. Height is m. kg m and m squared. What's your normal unit? kg m squared s minus 2. Force kg ms minus 2. Distance is m. M and m. What's your final unit? kg m squared s minus 2. All right, Viru? Work done. Kinetic energy, gravitational potential energy. On the side, you can put special note. Unitless means 1. Unitless means 1. Right. Just one more to complete the 15 there. We'll talk about in detail some more next week. Okay. So today we'll do till 2:30. Next week also same time 2:30. But we start at 12 next week. Huh? There. From July onwards we do up to 3. Okay. 12 to 3. 15. Have a look. Shh. Strain. Strain. What is strain? Yeah. What is strain? Not you strain, you know, that is not that strain. Mukkarudhu adilla. Sariya. This is what? Mechanical strain. Mechanical strain is change in length divided by initial length. Change in length divided by what? Initial length. Now change in length also unit is meter. Meter no? Initial length also meter. Meter cancel off. Answer is 1. 1 means what? Unit less. There are some physical quantities which are anyway what? Unit less. There. Okay then. Write this below. Strain. Change in length. Change in length. Okay. Right. So these what you should do at home. Number 1, 15 equations you know now. Some equations anyway you know. Some equations are new. Take a piece of paper, make sure you write the equations. You should remember the equation. Now next time I tell you how to find torque, quickly you should know what? For torque is force into perpendicular distance to pivot point. If I give you strain, you should know what? Change in length divided by initial length. There. If I give you directly, let's say, linear density, you should know what? Mass divided by length. If I give you surface density, you should know what? Mass divided by area. Next week, don't miss. We'll be doing the next part of this, which is what? Dimensions. That is where your A-level MCQ start. That is where we start doing all the past paper questions in your tube. Okay, no? Right. Okay, then, enough for today. I'll see you all next week. Please be here exactly by 12. We start the class by 12. Next week also 12 to 2:30. From July, we go what? 12 to 3. Okay, no? Right. Okay, then, get home safe. For the ones who need to write down the physics book's name. One. No, because the children are still coming. I started around 12:35 or 40, I think. First day, no? Okay, then. Online students, you can get further details, huh? Now you all joined by, you all got the thing, no? WhatsApp to those 2 numbers, and you can get further details. Okay, wait. Okay, right, got this. Okay, got this. Once you buy through the website, tudes and all you can take. All the tudes are provided. Online students. So online students, you understood this lesson? Okay. Okay. Those I have given you two numbers. Now you WhatsApp to them. Then they'll direct you. Huh? I have given two numbers. They'll direct you. Okay, now. Right. Any more questions? Okay then. Take care.